Okay, this is exercise 10.4, finding the greatest coefficient. Now, this is from your Margaret Grove textbook as opposed to Cambridge. Now, to find the greatest coefficient in a binomial expansion, we need to compare the k plus 1th term and the kth term. And what we notice in a binomial expansion, for examples such as the expansion a plus b to the power of n, is that the coefficients go up and then they will come back down. So to find the greatest coefficient, the k plus 1th term has to be greater than the kth term. And we're going to come up, what we're going to do in this exercise, we'll come up with an expression for the k plus 1th term, and that needs to be greater than the kth term. And if the k plus 1th term is greater than the kth term, then t sub k plus 1 over tk must be greater than 1, and that's what we're going to do. So we're just going to do a couple of examples here. First example is from exercise 10.4. It's question 20G, and that question is to find the greatest coefficient of this expansion, 3 plus 4y to the power of 7. The k plus 1th term, so tk plus 1, it's 7ck 3 to the power of 7 minus k times 4y to the power of k. And simplifying this, we've got 7ck 3 to the power of 7 minus k, and just breaking this up, 4 to the power of k times y to the power of k. So that's the k plus 1th term. Now I'm going to look at the kth term. So the kth term. Now notice that this k plus 1 is 1 higher than this k here, and this k is the same power as that. So the kth term will be 7c to the k minus 1. Okay, then it will be 3 to the power of 7 minus k minus 1 times 4y. Notice that if it's 7ck, it's 7 minus 3 to the 7 minus k, 4y to the power of k. This will be 7c to the k minus 1, 3 to the power of 7 minus k minus 1 times 4y to the power of k minus 1. And again, splitting this up, we've got 7c to the k minus 1. Now this is 3 to the power of 7 minus k plus 1 will be 8 minus, so 3 to the power of 8 minus k. Then breaking this up, we've got times 4 to the power of k minus 1 times y to the power of k minus 1. So that's the kth term. The ratio of t to the k plus 1 over t to the k, that's our next step. So we've got 7c to the k. Sorry, I'm just off the screen there. So now we need to work out t to the k plus 1 over t to the k. So we've got 7c to the k, 3 to the 7 minus k times 4 to the power of k times y to the power of k, over 7c to the k minus 1, 3 to the power of 8 minus k times 4 to the power of k minus 1 times y to the power of k minus 1. The 7ck and the 7c to the k minus 1, so 7ck over 7ck minus 1. Now let's look at our 3's. We've got 3 to the power of 7 minus k. Now here the bases are the same and we're dividing, so we subtract the indices. So we've got 3 to the power of 7 minus k, take away 8 minus k. Here I've got 4 to the power of k. Bases are the same, so we go k, take away k minus 1. And here we've got y to the power of k. And here again, bases are the same, we go k minus 1. And simplifying that, we've got 7ck over 7c to the k minus 1. We've got 3 to the 7 minus k minus 8, and that will be plus k. So we've got to the negative 1, okay? We've got 4 to the k minus k plus 1, so k minus k is 0, so it'll be 4 to the 1, times y. Now we've got k minus k again plus 1, and we've got y to the power of 1. So therefore we've got 7ck. On the numerator we've got 4y. and on the denominator we've got 7c to the k minus 1. And instead of writing 3 to the power of negative 1 up here, I'm just going to put the 3 down the bottom there, because that would be 3 to the power of 1 on the denominator. Now we're going to simplify the 7ck divided by the 7ck minus 1. Now the other thing you can notice here, notice we've been left with a 4 up on the numerator. This is because the power, this is 4 to the power of k, and this is 4 to the power of k minus 1. So we have one more, the power of 4 here is 1 higher than the power of 4 down here, which is why we're left with a 4 here. If you look at these 3's, 3 to the 7 minus k and 3 to the 8 minus k, we've got one more power of 3 here on the denominator than we have on the numerator, which is why we've got a 3 down the bottom. And if we look at the y's as well, see, for example, if k was 3, this would be y cubed and this would be y squared, so you'd be left with a y at the top. So there is one more power of y on the top than there is down the bottom, which is why we've got a y left on the top. So the next time you do this, simplify this, you don't have to do all this step here. You can just observe that this power of k is 1 higher than, this power of 4 is 1 higher than that. You'll be left with a 4 on the top. The power of y here is 1 higher than that, so you'll be left with a y on the top. And here the power of 3 is 1 higher on the bottom, on the denominator, than it is on the numerator. You'll be left with a 3 on the denominator. So now I'm going to simplify the 7ck over 7c to the k minus 1. Now 7ck is 7 factorial over 7 minus k factorial times k factorial. And we're dividing it by 7c to the k minus 1, which will be 7 factorial over 7 minus k minus 1 factorial times k minus 1 factorial, or I'm going to go times 7 minus k minus 1 factorial times k minus 1 factorial over 7 factorial. So I've done that divided by that, and we've still got times 4y on 3 over here. So now we need to continue here. I've just fixed up this times symbol. So I've got, notice that the 7 factorials cancel on the numerator and the denominator. Just be very careful here. I've got 7 minus k plus 1. So it's 7 minus k plus 1, which is 8 minus k factorial times k minus 1 factorial times, we've got the 4y over, we've got the 3 down there. And here we've got 7 minus k factorial times k factorial on the denominator. Now notice 8 minus k factorial is 1 higher than 7 minus k factorial. You can check this by just giving k any value. For example, k is 3. This would be 5 factorial over 4 factorial. So we're going to wind down the numerator by 1. So we've got 8 minus k times 7 minus k factorial. Now notice that the k factorial is 1 higher than the k minus 1 factorial. So I'll still put this 4y over 3. I've still got the 7 minus k factorial here. I'm going to write k factorial as k times k minus 1 factorial. So I've got k times k minus 1 factorial. Remember, I've got that times 3 still here. Now I can cancel the 7 minus k factorials. And sorry, I just missed out. I forgot. So, wait, 8 minus k factorial is 8 minus k times 7 minus k factorial. I forgot to write the k minus 1 factorial here. And I've still got that 4y. So that 8 minus k factorial is 8 minus k times 7 minus k factorial. Still have written this k minus 1 factorial times 4y. The 7 minus k factorials cancel. This k factorial is now k times k minus 1 factorial. The k minus 1 factorials cancel. And I'm left with 4y times 8 minus k over 3k. Okay, so that is my expression for the k plus 1 term over the kth term. Now I'm just going to continue over the page. Now we can say the following. Now we can say for the greatest coefficient we know that t to the k plus 1 is greater than t to the k, or we can say t to the k plus 1 over t to the k is greater than 1. So we just take this expression that we've got, which is 4y bracket 8 minus k over 3k is greater than 1. Now we know that k is positive because basically k, because we're doing the expansion of, say, 3 plus 4y to the power of 7, k lies between 0 and 7. So k is positive, so we can say, well, therefore 8y times 8 minus k is greater than 1 times 3k, which is 3k. Okay. Now, remember, we're just really looking for the coefficients. So, sorry, I should have just come back here. I basically want the coefficient, so the coefficient back here of t to the k plus 1 over t to the k. See, y will be, if you notice, this is the expansion of 3 plus 4y to the power of 7. The coefficient is the 4 bracket 8 minus k over 3k. So what I don't need here is this y. Okay, so I'll just pull that out because we're just trying to work out the value of k. So I'll just put that in the screen. Okay, so this term will have a y because with this expansion, the k plus 1 term compared to the k term will have an extra y in it, because as you expand, you know that expanding something like this, each term will differ by 1 power of y. Okay, so we've got 4 bracket 8 minus k is greater than 3k. In other words, 32 minus 4k is greater than 3k, which gives us that 7k is less than 32. So we've got 32 is greater than 7k, or 7k is less than 32. In other words, k is less than 32 on 7. So 32 on 7 is 4 point something. So k is less than 4 and I think 4/7. So therefore, oh sorry, that was just on the wrong page. So therefore k is less than 4 and 4/7. So therefore, for k equals, so for k equals 1, 2, 3, and 4, t to the k plus 1 is greater than t to the k. And for k is 5, 6, 7, t to the k plus 1 will be less than t to the k. So the term with the greatest coefficient occurs when k is 4. So it'd be the largest that k can be here. Okay, now you don't need to write this all the time. I'm just doing this in my explanation. So k needs to be less than 4 and 4/7. The first term that's less than 4 and 4/7 is k is 4. Okay, so k is 4 gives us the fifth term, because remember, t to the k plus 1 is t to the 4 plus 1, which is t5, the fifth term. And so working out what that term is, so we've got t to the 5, we know is 7c4, 3 to the 7 minus 4, 4y to the 4, which is 7c4, 3 cubed times 4 to the power of 4 times y to the power of 4. Sorry, just coming off the screen. And this bit's the coefficient, and the whole thing is the term. So just working out what 7c4, 3 cubed, and 4 to the power of 4 is. Just do that on the calculator. So we've got 7c4, which is 35, times 27 times 4 to the power of 4. Now that's pretty big. Times y to the power of 4. So I end up with 7c4, which is 35 times 27 times 4 to the power of 4, we end up with 241,920 y to the power of 4. And so the greatest coefficient is 241,920. Okay, that's the coefficient. The term is 241,920.